It's pretty wild to think that one of the biggest leaps in understanding our own minds came from, of all things, a bunch of rats running around in a maze. It sounds almost too simple, right? But this one elegant experiment completely flipped psychology on its head and gave us our first real look inside the so-called black box of the brain. So, let's get into it.
For a long, long time, this was pretty much the big question. The main theory was that all of us, animals and humans alike, were basically simple machines. You push a button, you get a response. You offer a cookie, a behavior gets learned. But is it really, truly that simple?
So, to really get why this was such a big deal, we got to look at what everyone believed before. We're talking about the era of behaviorism, a school of thought that basically saw learning as a purely mechanical thing. For early thinkers like John B. Watson, the mind, well, it was this black box. You weren't supposed to even try and look inside. Thoughts, feelings, ideas, all that stuff was considered messy, unscientific. The only thing that mattered was the straight line from a stimulus in the environment to a response you could see and measure. So this whole idea, they called it stimulus response, or SR theory for short. And the thinking was just super straightforward. Learning was all about building these connections. A bell rings, a dog drools. A light turns green, your foot hits the gas. No real thinking involved, just automatic reactions built up over time with rewards. But, there's always someone who looks at the accepted wisdom and goes, I'm not so sure about that. And for this story, that guy was Edward Tolman. He had a hunch that something much more complex, much more thoughtful was going on. And he came up with a brilliant experiment to prove it. This, right here, was Tolman's radical idea. He believed that behavior wasn't just a blind reaction. It had a purpose. A rat scurrying through a maze wasn't just randomly firing off a sequence of left turn, right turn reflexes. It was trying to get to the food. It had a goal. And to test this, he didn't use some simple little T-junction maze. No, this thing was complex. It was full of dead ends, tricky turns. It was designed to be a real head-scratcher for the rats. The real question wasn't just if they could solve it, but what they were actually learning as they went. And here is where it gets really clever. He split the rats into 3 groups. Group 1 was the classic setup. They got a food reward every single time they made it to the end. Group 2, no luck for them. Never got a reward. And then you have Group 3, our mystery group. For 10 straight days, nothing. Then, on day 11, the game changed. They started getting rewarded. And what happened with that 3rd group? Well, it was going to blow the doors off of everything psychologists thought they knew about learning. It pointed to something new, a kind of learning that happens invisibly, in the shadows, with no reward in sight. Okay, so put on your old school behaviorist hat for a second. If there's no reward, there's no reason to learn, right? No reinforcement means no new connections get formed in the brain. So when those group 3 rats finally get a reward on day 11, they should be starting from square one, yeah? Yeah, not even close. This is where it gets amazing. The first group gets better and better, nice and steady. The second group is just kind of wandering around, not really improving. But group 3, the moment that reward shows up, their performance just skyrockets. Almost overnight, they're not just good, they're better than the rats that were getting rewarded the whole time. And this incredible turnaround gave us a brand new term, latent learning. Basically, it's learning that's been happening under the surface all along. It's just hidden, latent, until you have a reason to show what you know. The food didn't create the learning, it just brought it out into the open. And this was the big takeaway, the huge aha moment. It created a powerful distinction between learning and performance. The rats in group 3 were acquiring knowledge the whole time, but without a good reason to, they didn't perform. The learning was happening all along. Okay, so they learned something, but what was it? It clearly wasn't just a simple list of turns. So Tolman came up with this really beautiful theory to explain what was actually happening inside their little rat brains. He pushed it even further with another genius experiment. He trained rats on one path, simple enough, but then he blocked that path and gave them a whole bunch of new choices. Now, the old SR theory would say they'd pick a path that feels similar, starts in the same direction. But that is not what they did, not at all. They overwhelmingly picked a totally new path, one that pointed straight to where the food should be. I mean, that's the smoking gun right there. They hadn't just learned turn right, go forward, turn left. They had built a mental picture of the maze's whole layout. They understood the space. And Tolman had the perfect name for this mental picture, a cognitive map. It's literally a map in the mind, a mental blueprint of our surroundings that lets us be flexible, find shortcuts, and solve problems creatively, not just repeat things we've memorized.
And you can see how this was just massive. This wasn't just about rats and mazes anymore. It was about us. It was about all learning. It meant that thinking, planning, and expecting things, all that mental stuff, was right at the very center of it all.
So it's a total shift in thinking, where behaviorism said learning is just mechanical, like a machine. Tolman said, no, it's purposeful. The mind wasn't a black box. It was a map maker. We aren't just reacting to things. We're building expectations about what's going to happen next. So think about the journey here. It really started with Watson's strict behaviorism, which basically said, that black box in the middle, the mind, don't even look at it. It's totally off limits. Then you had theorists like Clark Hall, who kind of peeked inside the box. They said, okay, maybe some internal stuff matters, but they were only talking about physical things, like being hungry or tired. The brain was still pretty much a machine, just with a few more dials.
And then Tolman comes along and just blows the lid right off the box. He puts all the good stuff, expectations, hypotheses, and those incredible cognitive maps, smack dab in the middle. This is the stuff that connects what happens out there in the world to what we actually do.
You really can't overstate Tolman's legacy. He showed that you don't always need a reward to learn something. He drew a clear line between knowing something and showing that you know it. And, most importantly, he made it scientific to talk about the mind again. He really did open the door for what we now call the cognitive revolution. Which kind of leaves you with the really cool thought, right? Think about all the invisible maps you're building every single day without even realizing it. From learning your way around a new city, to mastering a new video game, or even just figuring out the aisles of the grocery store. Your brain is constantly mapping things out. So the real question is, what have you learned today that you don't even know you know yet?